Okay, so you asked the question, how does condensation polymerization form nylon? So before we can answer that specific question of how condensation polymerization forms nylon, first we need to look at what is polymerization in the first place and what is condensation polymerization in the second place. So first of all, what is nylon? So nylon is made when the appropriate monomers or the chemical blocks, building blocks, which make up the polymers are combined to form a long chain via a condensation polymerization reaction. So the condensation polymerization is the chemical reaction, and the nylon is the product of that reaction. Now, the monomers for nylon 6,6 are adipic acid. So let's do this. So adipic acid, let me do that there. Adipic acid and hexamethylene diamine. So those are the ingredients. That's what you need to make nylon 6,6. Okay, so let's start off. And there's a video here if you want to watch. If you go on YouTube and say nylon production hydrogenation plant, it's a nice video you can watch on polymerization. So first of all, let's look at what is polymerization. So polymerization, let me make that bigger. Polymerization is the reaction of monomer molecules. So monomer means one. They are the monomer molecules that form the long polymer molecule. So monomer means one, poly means a lot. So from single molecules, from monomers, you can form long chains, and these chains are called polymers. So a monomer is a small reactive molecule that can be joined with other monomers to form long chains. In other cases, two monomers can be used. So you can either use the same monomer or you can use two different monomers to achieve polymerization. Okay, so that is what polymerization is. Now, we can also say that polymers are long chain molecules that occur naturally in living things, but they can also be made by chemical processes in the industry. Okay, so they're either natural or we can make them. Okay, so there are two types of polymerization. The first one is addition polymerization. Let me make this a small letter P. There's a reason I'm doing that. Small letter A. So there's addition polymerization and there's condensation polymerization. Okay, so we can first look at, I think we've already discussed what polymerization is. I'll just go straight into addition polymerization. So basically it's just adding, but I've put the notes somewhere else. So let's jump back to what is polymerization. And then I think I'm going to take the notes and copy them onto there. So condensation polymerization, we're going to look at this one after we look at addition polymerization. So this is condensation polymerization. But let's go into it after we've looked at addition polymerization. So let's see. What is polymerization? We're back here. There we go. So this is actually addition polymerization. So nylon, like I said, is made when the appropriate monomers, or the chemical building blocks which make up polymers, are combined to form a long chain via a condensation polymerization reaction. So this is the condensation polymerization. But before I look at condensation polymerization, I wanted to look at addition polymerization. So let's see if I can find that again. Let me see. I tried to look here, there was nothing. Here, there is nothing. Maybe here. Let's see. There are two types. What is polymerization? What is a polymer? It's called polymer. A long chain. Maybe nylon. Let me see. There's nothing on nylon. Okay, I did put some notes here, which I can no longer find. Let me try this one. Not there. Okay, some of my notes just disappeared. Let me try this. And then condensation. What is polymerization? Okay, let's just talk about condensation polymerization anyway. So if you look at here, the monomers that you need are adipic acid and hexamethyl diamine. Okay, let me see if I can annotate here. Let's see, maybe use a pointer. Yeah, for a spotlight. Right. Now I wanted a spotlight. Spotlight. Choose that one. Right, so I needed that. Can I still scroll up and down? Yeah. So this is adipic acid, and adipic acid is HO2C. Actually, it's C2OH. As same as here. I mean, let's see. So it's CO2H, just like this side, CO2H. So that's the adipic acid, and then it's got the CH2, which means there is 4 of these, and then these are by the side. And so that's the adipic acid. Then you've got the hexamethyl diamine, which is NH2, NH2, and then you got CH2, you got 6 of these in the middle. So the thing to note here is that when nylon is formed, okay, when nylon is formed, what happens is you get at the end here an NH, but originally what you had was, well, let's take this NH here. So you've got NH, can you see the CH2,6 is that CH2,6, and then the CH2,4 is that CH2,4. So around about here, some double bonds have been formed, okay? So let's have a look. So let's look at this carbon here. So this carbon here is that carbon there, okay? And this NH here is that NH here. So there were 2 hydrogens here, but now, I mean, here there were 2, now there's 1. So we've taken 1 hydrogen, and then we've taken this hydrogen as well, okay? So that means 2 hydrogens, 1 from here, 1 from there. That makes H2, and then we've taken 1 of the oxygens here, so that makes H2 hydrogens, and an oxygen have left. So 2 hydrogens and an oxygen have left, because now we have 1 instead of 2 oxygens. So that means an H2O has been released, and that's condensation. That's where the word condensation comes from, because you're losing H2O. So you've lost 1 of these hydrogens and 1 of these hydrogens, and then you've lost an oxygen. So that you're just left with CO, but it forms now a double bond. So that's the CO that's left. And then here you've taken one hydrogen, so you're left with NH, which is that NH. So now these two have combined, okay? And the same thing is happening at the other end, because this NH2 end is combining with one end like this one on the other side. So that now we have this here as a repeating structure. So this is what forms the long chain. So this is just two of them combined to form that, but you've got a lot of two of these doing the same thing and then forming a long chain. So that's condensation, polymerization. Now for nylon, there's nylon 66, which is this one. And then there's nylon 6, which is that one there. Okay, so nylon 6 is formed from caprolactam. And if you see a shape like this one, these corners are occupied by carbon atoms. So basically there's a carbon here, carbon there, carbon there, carbon there, carbon there. Then you've got a double bond. There's another carbon here, and it forms a double bond with oxygen. But here you've got a nitrogen and a hydrogen. And what happens is that some water is lost because it's condensation. And then you get a structure like this one, which is a little bit different from that one. In that here you've got one double bond, but here you've got two double bonds. I think that's where the 6-6 comes from, because you got two of these, and then here it's just one. So that's why you've got just 1, 6. Okay, so that's condensation, polymerization. But I'm still want to look for that addition, polymerization. See if I can find it. Seems it's not there. I have some diagrams to show just, I think, actually, here's two more examples. So how come I didn't see this? Okay. So I'm gonna show you two more examples of condensation, polymerization. So here we are going to form a substance called ethyl ethanoate. Okay, but to form ethyl ethanoate, you need ethanoic acid and you need ethanol. So ethanol is basically just some alcohol. So the formula for ethanol is 2,6H5OH, which is that. You can see there's two hydrogens, and then there's this 5, so C2H5, and then OH, which is that. And then you got ethanoic acid, which is CH3COOH. So CH3, then COOH. And so you can see the OH and the H, they form H2O, which is that H2O there. And then the ethyl ethanoate is just this double bond. You can see that double bond is the same one there. And then that carbon is that carbon, and then that oxygen is gone. That hydrogen is gone. That hydrogen is gone. So this is the oxygen, which is that one there. So this oxygen now combines with that carbon, and then the rest of it, which is that C2H5 is the C2H5, and then plus the H2O, which has been lost, which is the water. So again, this is an example of a condensation reaction. And then let's have a look at another one. This one is showing, instead of showing this a whole structure which is made of hydrogens and carbons here, we'll just put a blue box to make it easier so that we can just show the functional group or the group that's actually involved in the chemical reaction. So we've got a dicarboxylic acid and we've got a diol. And basically that's an alcohol and that's an acid. So an acid and an alcohol will give you this polyester here, and then water. So again, you've got the OH and you've got OH there. So this was the red one, which means here you're left with oxygen, that oxygen, okay? Which means that hydrogen was lost. So this one hydrogen and that one hydrogen and one of these oxygens, either this one or that one, that makes up the H2O. So when you lose H2O, you're just left with one of these hydrogens because you lost H2O, so you're left with one of the hydrogens. So one of the hydrogens, H2O, no, one of the oxygens. So this is the one oxygen that's left behind. And the same thing is going to happen on the other side, because this side is also going to react with another dicarboxylic acid. So this is condensation, polymerization. So with addition polymerization, it's just adding polymers, really, like ethene will form polyethylene and stuff like that. So let me see if I can find it using ethene, because I think I can find it. If not, it's a wait another day. Or I can just Google it now and show you. So let's see this one. The diagram shows, yeah, this is the one I'm looking for. Okay, so if you look at this diagram, this is just addition polymerization. So with addition polymerization, you just get the addition of polymers formed when smaller unsaturated molecules or monomers react together. So why unsaturated? Because they have double bonds. And instead of having, say, another hydrogen here and another hydrogen there, because that will get rid of the double bond, this is unsaturated. It's unsaturated because it does not have all the possible hydrogens that it could have. So if it had another 2 hydrogens, then it's saturated. But with just 4 hydrogens, it's unsaturated. So these two are the same. They are the ethene monomers. And when addition polymerization takes place, the double bonds disappear. It's as though they are becoming saturated. You see that? So this becomes a repeating structure. And you can multiply that by N, which is the number of monomer units that are joined together. So say you have 10,000 units or more, then you get a repeating unit, and that's addition polymerization. I think that should now make sense. I think I know what happened here. Let me try to fix it. So this addition polymerization, I know what happened. Let me fix that, because I made that one small letters and they all went to different places. So if I do this, it's going to tell me that addition polymerization already exists and match the pages. Yes. So now I've matched the pages. So now when I say what is polymerization, and I say that there is condensation polymerization, which is this, and I've explained that. And then if I go back and look for addition polymerization, then it should take me to addition polymerization. This is the link which was broken. Okay, so I think that's it for now. Thank you for watching.